right, AP Stats. Welcome, good morning, or good afternoon. So, today we are going to start our next unit, which is on Unit 9. It is about comparing two populations, which I mentioned was going to be the next thing we look at. Now, once again, notice we start by talking about proportions, then we'll get into means. So, just kind of keep in mind, similar to what we've done with intervals, with significance tests, now with significance test for a difference between proportions or means, that's going to be what we talk about in this unit. Hopefully, we're going to have enough time to get the test in before spring break is kind of the goal. That gives us a couple weeks to get through this, just as a timeline for kind of when we're going to be done. Now, notice the assignments, once again, have page numbers and problem numbers. Just note that, again, I'm working to make worksheets of all those for you so that you do not have to actually go to the textbook. All right, so today, what we're going to talk about, start by comparing two populations. So, first example. Is it harder to shoot free throws with distractions? A lot of people would think so, and as I've watched a lot of college basketball, you would think the distractions play some part in it. Now, to investigate, a basketball player went to the gym and shot 20 free throws. 10 of those free throws were shot without any distractions, and the other 10 were shot with his friends trying everything they could to distract him. The order of the 20 shots was decided at random, meaning we did not take 10 in a row of one shot and then all 10 of the next one. So, part A, why was it important that the order of shots was determined at random, rather than doing all of them of one type before the other type of shot? Now, a couple reasons for this. You want this to come from a random sample, because if you're going to be able to do anything with it, it has to be random. The other thing that this does, this helps to eliminate those confounding variables. Okay, now, part B here. The player made 50% of his shots in the distraction-free environment and only 30% in the environment with distractions, for a difference 50 minus 30 of 20%. Identify two plausible explanations for why the shooter performed better in the distraction-free environment. Well, the first one you should always answer. This should be your answer every single time as far as why a difference could be, is that it could just be due to chance. So chance variation needs to be your first answer every single time, meaning it could have just been an off day for him. We don't know. Could have just been that it was an off day. He just happened to shoot one way better than the other, just by chance. Now, the second thing should always be what you think is happening. In other words, we think that distractions truly do affect his shooting. Okay, so those should always be your two answers. Should not even have anything else there. Is the first one, chance variation, it could just have happened that way. The second one, distractions might have truly affected the shooting. Okay, so let's talk about sampling distribution of a difference. And again, notice that we're doing a SOX. Now the outliers for O fit in with spread. So this is the same SOX we've been doing for now the last 6-7 months. Okay, so first let's talk about the shape. When you are looking for the mean, which is what we are going to focus on for a proportion or a difference of proportions. So if you're looking for the mean, let's just say p hat 1 minus p hat 2. All you do there is take p1 minus p2. So you just take the two proportions, subtract. There is your center, which I guess, why am I talking about that here? Let's just move that over one. So center, move that over to this middle column here. But for the center, your mean of the two proportions, p hat 1 minus p hat 2, again, just take the two proportions and subtract them. Now, as far as any conditions, which is what this second row is. So the first row is kind of your description. Second column, or second row, I should say, is your conditions. Now, for the center, there are no conditions that need to be met. You're good to go ahead and do this anytime, no matter what. Now, for this first one that I kind of skipped over, this shape, normally you'll have something that's approximately normal. Now, the conditions that you need to check to ensure that it's approximately normal is you need to take n1 p hat 1 and multiply together. You also need for n1 and 1 minus p hat 1 and multiply those together. Then you do the same thing with the second population. So n2 p hat 2 and n2 1 minus p hat 2. Every single one of these need to be at least 10. So if you remember, for just a single population, we checked that this once, it's just n times p and n times 1 minus p. Because we're working with two different proportions and two different populations, that's why we have to check it twice. And all of those need to be greater than 10, or at least 10 to be approximately normal. Now, the very last one here is the spread. Now, for the spread, that's where you look at your standard deviation. So, to get your standard deviation, what you have to do when you're taking the square root of this, you need to take P1. So you need to take your P1 multiplied by 1 minus P1 over N1 plus P2 multiplied by 1 minus P2 all over N2. And all of this is underneath the square root. So for standard deviation of your spread, here that is. Now, the condition that needs to be met is still that 10 multiplied by n rule. In other words, both sample sizes, both n's, n1 and n2, must be less than or equal to 1/10 the overall population. In other words, if you multiply each of those by 10, they need to be less than or equal to your total population. Okay, so we're only going to do one example today, and then give you a chance to work on homework and finish that in class. All right, here it is. It says Nathan and Kyle both work for Department of Motor Vehicles, the DMV, but they live in different states. In Nathan's state, American manufacturers make 80% of the registered cars. In Kyle's state, American manufacturers make only 60% of the registered cars. So Nathan selected an SRS of 100 in his state, and Kyle selected an SRS of 70 in his state. We're going to let P hat sub n minus P hat sub k be the difference between the sample portions of cars made by American manufacturers. In other words, we're going to look at Nathan minus Kyle, is what that was saying. So as far as what is the shape of the distribution, basically whenever you are asked this question is you're trying to decide if it can be said that it's approximately normal, meaning you've got to take n times p for all of the different scenarios and n times 1 minus p. So let's look at Nathan first. Nathan had an SRS of 100 and he had a proportion of 80. So we're going to take 100 multiplied by 0.8, which is 80. We also need to take 100 multiplied by 1 minus 0.8, which is 0.2. 100 multiplied by 0.2 is 20. And now we're going to do the same thing for Kyle. Now for Kyle only did 70 cars, and his proportion was 60%. So we're going to take 70 multiplied by that 60%, 70 multiplied by 0.6, which would be 42, and then 70 multiplied by 1 minus 0.6, so 0.4, which is 28. Now, notice that all are at least 10, so what we can say is that the sampling distribution is approximately normal. If they were not all at least 10, then you cannot say anything about the shape without actually going through and graphing it. So just note that what you would say there, you'd just say not approximately normal, do not know the shape. Okay, so now finding the mean, which is going to be the easy one. If you want to find the mean, and keep in mind we're taking p hat for n, so for Nathan, minus p hat for k for Kyle, which would be taking 80 or 0.8 minus 0.6, which ends up being 0.2, so about 20%. That would be your mean. Okay, now last one here, find the standard deviation. So for standard deviation, that's where you look at the formula. Now before we do, let's just make sure conditions are met, since we do have some conditions we need to think about. So for Nathan, there were 100 cars, so 100 multiplied by 10 is 1,000. Can we assume that there are more than 1,000 cars in his state? And I would say yes. No matter what state you're in, you're going to have at least 1,000 cars. For Kyle, it was only 70, but still 70 multiplied by 10 is 700. Can we assume that there's more than 700 cars? I would say yes. Even in Alaska, they probably have at least 1,000 or 700 cars. Okay, now for the actual equation itself, we're going to say that our standard deviation is equal to this. We've got to take P1, so 0.8 for Nathan, multiplied by 1 minus 0.8, so 0.2, and then divide by n, which was 100, plus Now we're going to take our P for Kyle, so 0.6, multiplied by 1 minus 0.6, so 0.4, divided by our sample size, which is 70. And then just put all that into a calculator, so let's see what that ends up being here. I'll type that in real quick for us so you can check and make sure for me. Okay. And what I am getting here, I'm getting an answer of, it looks like 0.0709. Let me just double check and make sure I type that in okay for us. Okay, looks like we're good to go. So on your homework today, you're going to find a couple problems just like that example that you can work through so that you can kind of get through those. You will also find another example from a kind of frappy type problem that takes you all the way back to like unit 2 or 3, just as a practice, especially because we're looking at starting to get ready for that AP test in May. Now, that's another thing I did want to mention to you guys. Remember, the deadline for registering for the AP test is Monday. You've got to get registered this weekend if you want to take that to get college credit in this class. If you don't register for it, you can't do that. So, all right, guys, I will see you on Monday. Have a great rest of your